Okay, good evening guys. So this time in this video, I will try to continue my last video about stoichiometry, the concept of mole. So I have already told you about the bridge of mole that I have written in this paper. So this time I would like to tell you about the example of the concept of mole and the application of the concept of mole in that bridge. So I would like to write again about the concept of mole, but in this time I would like to tell you about the numbers of particles and mass only. So I would like to tell you about these two things only for this video. So have you understand about my last video? So if you have understand, then you're a good person. So you can do it in your task or in your school task maybe, or maybe you just understand it and make yourself have a better explanation and understanding about mole. So in this time I want to tell you about the example of my number of particle and mass. To remind you again, so in this so this is mole, and the left side is the number of particles, and the right side is mass. Okay, so these three things that we are going to explain it now. Okay, so the first example is just like this. You have to count the mole of 12 multiplied by 10 to the power of 23 particles of calcium. So how much mole is this? So this is, so if you need to convert number of particles, you already know the particles of calcium is about 12 multiplied by 10 to the power of 23, right? So if we want to convert number of particles to mole, then you have to divide the numbers of particle with Avogadro number. So in this time I can write this 12 multiplied by 10 to the power of 23 divided by numbers of Avogadro. Have you understand? Have you remember about the numbers of Avogadro? So its result is 6.02 multiplied by 10 to the power of 23. But in this time, because 12 is the multiply of 6, then we can just round up into 12 multiplied by 10 to the power of 23 divided by 6 multiplied by 10 to the power of 23. So 6.02 can be round up into 6. I'm sorry. Yeah, so if the count is easier, then you just write like round up the 6.02 into 6. That's all. Okay, and then we just divide it. Is 6.6 to the 10 to the power of 23 divided by 10 to the power of 23 is 1. Okay, and 12 divided by 6 is 2. Then the result is 2 moles of calcium. Then what if the question will be like this: how many moles of 18.06 multiplied by 10 to the power of 24 particles of Can you read this? You know that N is nitrogen and H is hydrogen, so we can read it into nitrogen trihydrate. Okay, so we ask this: how many moles of the nitrogen trihydrate? Okay, it's just like the same. So the 18.06 multiplied by 10 to the power of 24 is divided by the numbers of Avogadro is 6.02 to the multiply by 10 to the power of 23. Then we can divide it. Here 18.06 divided by 6.02, result is 3. And this time 10 to the powers of 24 divided by 10 to the powers of 23 is just like 10 to the powers of 24 minus 23. So it results 3 multiplied by 10 to the powers of 1, or 30 moles of nitrogen trihydrate. Okay? And then number 3. What if the question will be like this? How many particles of 1.5 moles of barium sulfate? How many particles? Okay? If you have a question like this, then it will be reversible than before. So if you want to convert moles into numbers of particles, then we just multiply moles with Avogadro's number. So it's just like 1.5 multiplied by 6.02 divided and multiplied by 10 to the powers of 23, and its result 9 multiplied by 10 to the powers of 23 particles of barium sulfate. Okay, so that's all about converting numbers of particles to mole and moles to numbers of particles. So this is the really easy example of the application of concept of mole. And then we just talking about mass. Okay, so I give you some example. What if the question will be like this? Question number 4. We need to convert mole into mass. So what if the question will be like this? How many grams are there in 4 moles of sulfur? Oh, how many grams? Yeah. How many grams of 4 moles of sulfur? So based on the concept of mole that I have told you in last video, so to convert mole into mass, then we just have to multiply mole to remember this? AR itu stands for atomic relative mass, MR stands for molecular relative mass, AR is for atomic, and MR is for molecule. AR is for atom, I'm sorry. Okay, so in this question, sulfur is atom, right? So if sulfur is atom, then we just multiply the mole with atomic relative mass of sulfur. So we just write this time just like 4 multiplied by atomic relative mass of sulfur. Okay, now you guys have to know how much the atomic relative mass of sulfur. If you don't know, then you have to check your periodic table. Okay, so the mass number of sulfur is that the atomic relative mass of sulfur. So the atomic relative mass of sulfur is 32. So 4 multiplied 32 is 128 grams of sulfur. Okay, and the last question in this video, number 5. We need to convert mass into mole. So what if the question will be like this? How many moles of 124.25 of chlorine? I'm sorry, 124.25 of chlorine. How many moles are there? Okay, based again on my bridge in last video, so if you need to convert mass to mole, we just like divide mole with atomic relative mass of molecular relative mass. Okay, so in this time chlorine is an atom, right? Chlorine is an atom, so we just like mass divided by atomic relative mass of chlorine. So we can write like this. I'm sorry, this is grams, yeah. Okay, so we can write like this: 124.25 divided by atomic reactive mass of chlorine. Okay, if you don't know how much the atomic reactive mass of chlorine, then you have to check your periodic table. Okay, and the result is 124.25 divided by 35.5, and the result is 3.5 moles of chlorine. Alright, so that's all my videos for this time. This is about the most easy example about this concept of mole. Maybe I will return in the next week or 2 weeks later about another concept of mole, about volume and molarity. That's all. See you soon.